within arm's reach. All right, decay series. Now we're going to be looking at multiple decay reactions for one particular parent, and it needs to go through all of these in order to eventually achieve stability. So highlight along with me as we go. It's a step-by-step process. All right, decay series is steps which the unstable nuclei decays into the stable one, but it takes multiple steps in order to do that. Just reviewing again real quick, small atoms are stable when their ratio is close to 1 to 1. The larger atoms are more stable at 1.5 to 1. That's why the band of stability, as it gets larger, comes off the 1 to 1 line. Okay, so we're going to be looking at and following our rules here. The alpha decay makes the nucleus smaller by giving 2 protons and 2 neutrons away. And this tends to happen when we have much larger nuclei. So this happens in the larger ones, alpha decay. Beta decay is for the ones that have lots of neutrons. Neutron rich. Getting rid of neutrons, changing them into protons, reducing that ratio. Tends to happen when there's too many neutrons. Okay, that's the idea there. We have to follow a few rules as we're starting the decay series. When you're starting the decay series, keep these in mind. If the atomic number is greater than 83, that means it's very large and it's going to undergo an alpha decay. The atomic number is at or below 83, it's going to undergo beta decay. And you need to keep going and have your calculator out until you figure out that the ratio is 1.5 to 1 or less. So you keep going until you get to that point. The other point that you have to do and keep going to is tell the atomic number is at or below 83. So 2 concepts to keep going until you get to 83 or below, and you also have that ratio of 1.5 to 1. So we're going to do the decay series together for radon 222. And it's going to take multiple steps. All right, so let's go. Starting here with our first one. We have 222Rn, which happens to be 86 on the periodic table. Now, if we're looking at our rules that we just talked about, which type of decay is it going to go? So we're going to undergo alpha. Very good. So we can stick in our alpha particle, okay? And then also get our new daughter element here, which is going to be 218 and 84. 84 happens to be which element? Polonium, right? Now, polonium, being the daughter element, is going to start the next series. So it's going to come over and drop down and become the parent of the next line. Now, if we're still following our rules here, are we going to undergo alpha or beta? We're going to undergo alpha because we're still above 83. So for 2 helium, what are we going to get out of this one? 214 and 82, which happens to be lead. Very good. Now, at some point, like, hey, it's probably too early, but we can check it. How do we check the neutron to proton ratio? We've got to take our 214 and do what? Subtract the 82. When you do the 214, subtract the 82, that gives us our neutron number of 132 neutrons, divided by your proton number, and we end up with what ratio?
1.66.
This is 1.61. So we're not close yet to getting down to 1.5. We got to keep going. So we're going to take our lead over here and start the next one. Now, which type of decay are we going to undergo here? We need to undergo a beta because the atomic number is less than 83 here. So it's going to undergo a beta decay. So put in a beta decay. What do we get as the daughter in this case? 214 and 83. 83 happens to be bismuth, a pretty crystal. Rectangular crystals that are rainbow colored. They're very pretty, by the way, bismuth. Now, we're going to take our bismuth. We could check the ratio again, but I'm pretty sure we're way above 1.5 to 1. And we're going to start the next one. What kind of decay is it going to undergo for following our rules? It's still a beta because we're at or below 83, so we do beta here. So keep it with the beta. And what do we get? 214 and 84. And 84 is back to which element? Polonium. All right, PO. Okay, PO. You can also go over here and check your neutron to proton. 214 minus 84. 214 minus 84 gives us 130 neutrons over 84 protons. What do we get there? This is 1.54. Still not there yet. Let's keep going. Now we're going to take the polonium. 214 here. And what type of radioactive decay is it going to undergo? It's going to undergo alpha because it's 84, which is above the 83, so we would want to go for an alpha decay here, following our rules. And out of this we get 210 and 82, so now we're back to lead. Okay, so let's check our ratio here. See what we have. We have 128 neutrons over 82. And what does that end up being? 1.56. Ratio did not improve. Let's keep going. So what kind of radioactive decay are we going to undergo if we're at lead again? It's now a beta. Let's go back to beta. 0 minus 1e. Okay, what do we get out of that? We get 210, 83, which is bismuth again, right? You can check that ratio here. Let's do that.
It's 1.53.
1.53, still not there yet.
1.5.
What kind of decay are we going to undergo here? Another beta. Let's keep going. We're almost there. I promise you're almost there. This is going to be 210 and what? 84. So 84 is back to polonium. What's the ratio now?
Exactly.
But there's a problem. What's the problem? This is a ratio of 1.5 to 1. However, look at your atomic number. We have to do one more to get it back below 83, right? Yes, exactly right. Because we have to have it below 80 or 83 or below, right? In order to stop, we have to have a 1.5 to 1 ratio in order to stop. So both criteria have to be met in order to stop the decay series. So let's look here and transfer it over. We have 210, 84 polonium. It's going to undergo which one?
Alpha.
Alpha. Hopefully it's our last one. Let's hope it is. And we end up with 206, and it's going to be 82, which is back to lead. Let's check the ratio, make sure it's all good. It ends up being 1.51 to 1, so we get to stop our last ultimate daughter here. Oh my God. Now the decay series that we would give you on a test or quiz would not be this long. It'd be like 3 or 4 steps. We wouldn't give you one that goes on forever and ever. Realize though that uranium-238 actually undergoes, I think, like 10 to 12 steps. I can't remember exactly, but it's even longer than this. Okay?
It's fine.
So, decay series, you can start on the nuclear part 1. We will do half-life next class. So you will be able to do your nuclear part 2 after that.